The last elimination method teaches you how to deal with solving a system of equations algebraically whenever the coefficients don't match at all. So let's do A and B on this video. So here's my system, and I can see that the coefficient on x, the coefficients on y, they're not additive inverses, they're not the same, so I'm going to have to force something to happen. So I would analyze this system. I think the easiest thing to do would be to eliminate y. So I'm going to copy the first equation over. And if I were to multiply the second equation times positive 2, then I would have negative 2y and positive 2y. So my second equation turns into this. And I would have to multiply each term in the second equation by the factor of 2. And now I'm set up for my vertical addition. So I'm going to have 11x, y is going to eliminate, and then I'm going to have 4 plus 18 is 22. So therefore x is 2. And then I would go back to either original equation to find y. So now my job is to find y. And I'm going to go back to the second equation, because to me it looks like the equation that requires the least calculation. And if x is positive 2, I'm going to have 6 plus y. 6 plus y is 9, therefore y is 3. So the solution to the set in problem, or the solution to the equations in problem set A would be the ordered pair x is 2, y is positive 3. Let's do one more together. Let's do problem set G. So here in problem set G, I'm going to have to manipulate both equations. So I'm going to, and this is just a choice, I'm going to choose to eliminate y. Okay, if I'm going to eliminate y, I'm going to multiply the first equation by positive 2, and I'm going to multiply the second equation by negative 5. That's going to force me to have a coefficient of negative 10y and then a coefficient of positive 10y, so that when I do the vertical addition, the y's will eliminate. If I wanted to eliminate the x coordinate, let's just make an illustration here so to help you understand. If I wanted to eliminate x, let's say now my choice is to eliminate x. I would multiply the first equation by 5, and I would multiply the second equation by negative 3. That way I would have 15x and negative 15x, so that when I added those together, they would sum out to 0. So let's run through one full example on the video. Let's just now go with eliminating x. So if I were to multiply the first equation by positive 5, I would have 15x minus 25y. So 15x minus 25y, and that would be set equal to 35. And then taking care of the second equation, I would have negative 15x plus 6y's equaling positive 3. So now I'm ready to do my vertical addition. And let's see what I'm going to have 38 equaling 38. This is going to sum out to 0, and I'm going to have negative 19y. So the value of y is going to be negative 2. And then to go back to either original equation, if y is negative 2, and I'll just simply go into the first equation, let y become negative 2, and that means I'm going to have 3x plus 10 equals 7. So 3x is negative 3, therefore x is negative 1. So the solution for the set given in G would be the ordered pair negative 1, negative 2.